I missed you.
Okay folks, normal service has been resumed. Let's move. Someone asked me, how do you get from nothing to a working Ford program? As usual, it depends. It mostly depends on how familiar you are with the algorithm, because in Ford, an algorithm is very important. It's like a plan. You don't get from 0 to 60 all freewheeling using Ford. You can do that in BASIC or even in C, but not in Ford. Because there's always the stack, and if you overflow it with values, that's it. Start anew, you won't recover from that one. Now, if you designed that program yourself, you're probably quite familiar with that algorithm. Most likely you've kept the number of values on the stack very low. Most likely you've designed it like a Matryoshka doll, each layer having its own very limited set of stack values. But if you lack that familiarity, you will either try to obtain it or rearrange it, so you will at least get some of these typical Ford characteristics. The first step is to break up large functions into small words, and rearrange the variables in such a way you can assign them to these new layers. Consequently, you will change the stack diagram in such a way that it suits the new layer best. You will most definitely recognize that in my own programs. In my opinion, the best Ford programs are born if you reject the given solution completely, take a fresh look at the problem, and come up with a fully different solution, one that fits Ford much better. So how you solve it will largely depend on how you go about it. Well, in Ford it does. If you have to recode something in Ford, I often implement it first in uBasic Ford, just to get a feel of it. It allows me to introduce new layers and to regroup the parameters. If a function has too many parameters, I know there's still work to do. In this case, I broke up the major routine in 3 words, the main Chao routine, and a permute left and a permute right word. The Chao word seems a bit overloaded with 4 parameters and 3 temporary values, but one of these parameters, a flag, is rarely used. Real return stack material. Another one, the length, is only used in a while evaluation. I also turned the 2 parts of the if statement into 2 function pointers. That doesn't just save me an if statement, but also a silly parameter. Now that huge function has just become not only a lot shorter, but also a bit more manageable. In Ford, we need things manageable. Take a look at the encrypt and decrypt routines. They're almost identical. Now, a C buddy would probably think, I can get this a bit more dry. But take a look at the number of parameters. We're already at 3 parameters. Given you want to make it a Ford program, do you think it's a good idea to add 2 more? After all the juggling, how much code are you going to save? Given that you also have to introduce 2 new words feeding the parameters to the generalized routine. So, not now. Let's see how this works out. Note I had to add the command poke to uBasic to make it work. But hey, if you got that option, why not? I didn't write this thing for nothing. And another thing, arrays are different. And yeah, strings are just arrays, so what? Well, if I have to take the value of a variable and put it on the stack, I can do away with the variable. All that variable was, all that variable represented, lies intact on the stack. With an array, that is not the case. First of all, an array is random access. No way a stack can replicate that. Second, a stack has a limited size. In general, it is much smaller than your average array. Sure, I can store a pointer to that array on the stack, but that's just a direction sign to the array, not the array itself. You can live in Berlin, but not in a sign that points to Berlin. So, unless you want to feed that routine a lot of different arrays, there is no need to feed that routine a pointer. More so since all arrays in Ford are global. So if you ever heard the motto stamp out the variables, you shouldn't interpret that as stamp out all the arrays. Bad idea. And for all those reasons, there's nothing wrong by using the actual array names in this case. Now we can use the main routine. A few initializations and 2 calls to the Chao routine. One for encrypting and one for decrypting. That's it. Now let's do 4th. I beg your pardon? Do you actually suggest I use a different Fort compiler? Are you serious? I'm afraid not, sir. As we expected, the main word is nice and clean. And the Chao word is already complex. We have to offload the print flag to the return stack to create a bit of space. Getting just the length of the input array requires a bit of effort. And yes, dump it on the return stack. What else? And while we're at it, we need a counter, folks. Sorry. Now, why didn't we just rearrange the stack diagram? Because a few lines later, we require all these stack items in exactly that order. Of course, we're in a loop. That means we cannot just spend them, we have to save them for the next iteration. So that's where 3dub comes in. The rest is pretty boring, just increment the counter. It also becomes clear why we didn't try out the encrypt and decrypt words. It's already so busy on the stack, we need the return stack to help us out. And note, if you really want to clean out these words, you can, and not just the C way, the Fort way. But can you actually name what these words do? Get the value of an array below and add the address of the top array? Sure that's a piece of recognizable functionality? Now try porting the whole shebang to vanilla Fort. The Fort that uses counted strings, instead of ASCII set strings like 4th. So we have to insert counts everywhere. And drop the count. Gee, that will really help. I'd love to debug that one. Or we can just introduce a handful of ASCII set routines, along with a bunch of other non-ANS Fort words. So we have to change nothing at all. What do you think? What's best? And ending with that mind-bogglingly brilliant solution, I'm Hans Bezemer, and this was Back and Forth.
Last, I would like to thank everyone who liked, commented, and subscribed.